Hello, this is Mr. Wyrick. I'm ready to talk to you today about Lesson 11.1, the first lesson of Chapter 11. We're going to be talking about the areas of triangles and parallelograms. Most of Chapter 11 is going to be covering areas of different figures, so we're going to start by kind of reviewing ones that you may have already seen. The first couple things on here are the base of a parallelogram and height of a parallelogram. Okay, the base is essentially the length of one of the longer sides, or the length of the side. And really and truly, it doesn't really matter which side. It's kind of up to you how you're going to approach this. Typically, it's thought of when it's sitting like this and you see a parallelogram, you treat this bottom one or this top one as a base. We refer to them as a base. And then the height of the parallelogram would be the distance from one base to another. Okay, they have a slightly different definition here in the book, and that's on page, let me get the page for you. On page 779, they go ahead and say specifically perpendicular, but I think you know if you're doing distance, it's going to be perpendicular. So these dotted lines here would be an indication of the height of that parallelogram. So we have postulate 11.1, the area addition postulate. The area is the sum of the areas of the non-overlapping parts. So if we take this parallelogram and we cut this triangle off and move it over here, it's essentially a rectangle. So we could, if we wanted to, we could cut off both triangles, find the areas of those triangles, and then find the area of the rectangular piece in the middle and add those together. That would be an acceptable method for finding the areas. And the area addition postulate has some application later on where it's a semicircle drawn onto the side of a triangle or some kind of irregular shape where you can calculate each portion and then add the whole thing together to find the area. And this is especially helpful when you're dealing with three-dimensional shapes and you're trying to find surface area of three-dimensional shapes that are irregular. It can help you out a lot. So the next thing you need to know is the area of a parallelogram. It's just like a rectangle. The area is equal to the base times the height. That's how it's always listed. It's how it's referred to whenever you have standardized tests up to and including PSAT, ACT, those college entrance exams. So we take that base, we understand that the height is not this slanted line here, but this directly up and down. And so we multiply the length of the base times the height. That'll give us the total area. Postulate 11.2, if two figures are congruent, their areas are congruent. This can help us out by saying, okay, I know that if we have a parallelogram and we make this diagonal here, it will cut it into two congruent triangles. So if I can find this triangle, then if I'm supposed to reflect it across that line and make it into a parallelogram, I know that the area of this triangle and the area of the other triangle are going to be exactly the same. I can just multiply it by 2, which leads us backwardly to finding the area of a triangle, which is 1/2 of the base times the height. Same kind of thing. We typically think of this one that's the lowest as being the base. I just wanted to put up here a quick note. Make sure you add this to your notes. It doesn't actually matter which base or which height it is. The area of the triangle should be the same no matter what. So on this one, it's kind of an odd-shaped triangle. But if I were to draw this height down here like this, I could use this as my height and this is my base. Or if I know what this side is and I have this altitude, I can use that altitude as a height and use this as my base. Or if I turn it like this, this is going to be the more difficult one is I have to use this as a base. Then there's going to be this height that would be at 90 degrees to that base that I could use. But for any one of them, it should all be proportional. We should have the exact same number, the same product when we multiply the base times the height, regardless of which one we're using as the base or the height. Should be a fairly simple, straightforward lesson. All we're doing is calculating areas of different figures just be sure to understand what it is that they are asking for in any specific one, because these are not overly complex formulas. So through the lesson, I expect them to have you apply it in some different ways. Today we will be working from this one. We'll do numbers. I almost forgot to put this on here. We'll do number 10 all the way through. We'll do quite a few of them because, again, it's not going to be overly complex. We'll do 10 through 38 for the homework problems today. If there's any part of this that you don't understand, or you take a peek at the problems and it looks like something's not going to make a lot of sense, make sure to ask during class, and we'll see you then.